Welcome to the short educational video based on the ethics for autonomous and intelligent systems. The main purpose of autonomous and intelligent systems is to reduce human intervention as much as possible in our daily lives. They are designed to do the mundane tasks that we don't want to do. However, excessive automation can lead to job loss and diminishing human proficiency. So where can we draw the line on what is beneficial or harmful? That is where ethically aligned design comes in. The goal is to put into place certain limitations to ensure these systems impart a positive impact upon the world. It is important to recognize the effect these systems have on privacy, economy, social well-being, and security, as well as how effectively they mitigate discrimination and loss of skill. You may be thinking, why is this important? Well, as engineers, it is crucial to understand our work's influence and ensure it doesn't negatively affect individuals or society. Ethical engineering builds trust with the public, allowing for widespread adoption of our products. It is essential to innovation with purpose, as design should have thoughtful consideration of their societal implications. Applying this ethical approach will allow for innovations that address real problems. Therefore, it is vital that we embrace ethics, not just for the sake of our morals, but also for the betterment of humanity. It can be quite difficult to quantify how well a device adopts ethics. However, there are 5 general principles outlined by IEEE that guides engineers to more ethically aligned designs. It is important that autonomous and intelligent systems do not violate internationally recognized human rights. Designs should prioritize well-being, i.e., considering mental health and sense of self. Accountability makes certain that all parties involved from the design to its use are responsible and accountable for the device. Transparency informs users of system limitations and required autonomy levels. Awareness of misuse is understanding of the dangers involved if the device is used inappropriately. But how can we make sure that autonomous systems adhere to these principles? The principles themselves are too vague and can vary by culture. It is essential to consider a variety of views to remove bias and discrimination if our designs offer worldwide use. This leads us on to classical ethical practices. Buddhism is the first. This practice aims to reach nirvana, where actions that liberate from desire, anger, and delusion are assumed good. Applying Buddhist ethics to autonomous systems should promote the goal of achieving liberation by minimizing suffering and encouraging harmony in communities. Ubuntu is an African practice emphasizing community. The act of belonging is linked heavily to the idea of being. Much like Buddhism, technology should supplement communities and avoid undermining them. Shinto regards the natural world as possessed by kami, which are revered by its followers. This concept extends to robots, with the belief that these technologies are also possessed. Japan, where Shinto originates, has this practice already in effect, as the country is widely integrated with autonomous systems. Aristotelian philosophy pursues eudaimonia, allowing individuals to reach their full potential through integrity, fairness, and honesty. Designs must uphold these values and enable users to achieve eudaimonia. The means justifying the end can sum up Kantian ethics. Individuals' actions must be carried out under universally applied morals, irregardless of the consequences. Systems should respect human autonomy and uphold universal ethical principles. The 5 virtues defining Confucian principles are applicable to autonomous systems. Ren, systems should promote the well-being of society. Li, they must have etiquette in their interactions with users. Zong, prioritize ethical considerations over self-interest. Xiao, respect authority and guidance of human users. Yi, must have justice and righteousness in their actions. It is crucial to include these practices in our designs, but it can be contradictory to include them all. Due to distinct cultures, it can be challenging to implement Kant's universal morals. Buddhist ethics of assuming good conflicts with Western ideologies prioritizing critical thinking. There's also clashes between Western and Shinto views on artificiality. It is also unproductive to have Western ethical practices dominate autonomous systems. It is important for engineers to strike a good balance so that there is widespread adoption of their work. Now that we understand the framework of ethically aligned designs, let's consider embedding these values into autonomous systems. In a scenario where a self-driving car faces an unavoidable crash, how should the vehicle behave? Should it prioritize the safety of the passengers, pedestrians, or select the option resulting in the least fatalities? Who should be held accountable? The manufacturer, programmer, or owner? This scenario parallels the classic trolley problem, posing challenges for engineers and ethicists in incorporating it into autonomous systems. Tesla, the largest company at the forefront of self-driving technology, faced legal action in 2016. The issue arose when Tesla made the decision to not use its automatic emergency braking system when users were in control of the car. They ensured user autonomy despite potential harm to themselves or others. So, should humans retain full autonomy, or should systems be used as intended and remove humans from the equation? This is a challenge faced by engineers as this technology becomes more pervasive. There arises the need to embed values into systems, yet there is no universal standard. Instead, we need to identify suitable values for different systems by examining community norms, applying them to a system, and confirming successful implementation. Confining ourselves to ethical engineering ensures a progressive world that is beneficial for all. This brings us to the end of the video. Thank you for watching.